Hello, I'm Professor Chiban Acharya. In this video, I'll do the homework from section 3.4. Section 3.4 is about the measures of position and outliers. That's the topics. First question is formula question. The question tells you is that the statement is true or false. In other words, is this formula to find the z-score is true or false? And this is the false because you see standard deviation here subtracted from data item. That's not correct. It must be z-score equals to data item minus mean over standard deviation in the denominator. Therefore, the answer for this question is part B. The formula is false. It's not correct. The correct formula is z-score equals data item minus mean divided by standard deviation. Question number 2. A set of data item has a mean of 40 and the standard deviation of 10. Okay, they are given mean and standard deviation. Convert the data item 15. Here 15 is the data item. 15 is the data item to z-score. And another word, what is the z-score for 15? That's what I'm looking for. And z-score of 15. Sometimes we can write z of 15 as a subscript to write z-score of 15. It's not necessarily you have to put 15 as a subscript, but that's okay. Equals to the formula here. We know that data item, which is 15 minus mean in the formula, which is 40, and divided by standard deviation, which is 10. Okay, and this gives you a negative 25 divided by 10, and that's going to be negative 2.5. Therefore, the z-score of 15 is negative 2.5. That's the answer. Question number 3. This question is basically application of the z-score in the statistics, and this is a little bit longer question, so you got to read very carefully. Suppose the baby born after a gestation period of 32 to 35 weeks have a mean 3000 gram and the standard deviation of 800 gram. Okay, while remember that this is the first part here. You have the mean and standard deviation of the baby who born between 32 to 35 weeks. Also, the baby who born after gestation period of 40 weeks has a mean weight of 3300 gram and a standard deviation of 400 gram. Well, let me summarize this here. You have 32 to 35 weeks gestation period baby, which has a mean of 3000 gram. Standard deviation, I write SD equals 800 gram. Okay, I didn't write the gram here. And other part here, for 40 weeks gestation, mean is 3300 gram. Standard deviation is going to be 440 gram. You see here. Okay, and look at the last sentence. If a 30-week gestation period baby weight 3150 gram and 41-week gestation period baby weight 3450 gram. Okay, listen, this is the data item. 3140 gram is the data item here for the baby who born with 36-week gestation. Therefore, I should say in this case data item here is 3150, right? 3150. And the data item for second group of data set is 3450 gram. Listen, 41-week gestation period baby weight 3450. Therefore, here data item going to be 3450. You see the two set of data item here. One is the between 30 to 35 weeks, other is after 40 weeks. Okay, I see. Therefore, this is the weight of the baby who born at 34 weeks. This is the weight of the baby who born at 41 weeks. And we are looking for z-score of each data item, right? Find the corresponding z-score, and we need to answer which baby weight is relatively more. Okay, and to do that, we got to find the z-score of each data item. Let's find z-score of 3150. Notice that that's how I put the subscript to mention that this is the z-score for 3150 data item. And what's the formula? Data item minus mean is 3000 divided by 800. Notice mean is 3000, standard deviation 800, and that's the formula comes from question number 1, right? If you divide and round it to 2 decimal places as the instruction says, you get 0.19. Similarly, you got to find z-score of 3450. The data item is 3450 minus 3300 divided by standard deviation 450, and you get, when you divide this difference by 450, you get 0.34. Okay, and you notice that this 0.34, which is the z-score of 3450, is higher than 0.19, was the z-score of 3150. Therefore, in this question, the answer is C. And the baby born in 41 week weight relatively more, since the z-score, what's the z-score of 41 weeks born baby? 0.34. 0.34 is larger than z-score of 0.19, which is the z-score of the baby who born in 34 weeks. Okay, that's the question number 3. Question number 4 is similar to question number 3, and also question number 5 is similar to question number 3 and 4, but I'll do question number 5. Okay. 1 year Thomas had a lowest ERA. ERA stands for on run average of any male teachers at his school with an ERA of 2.77. That's the ERA of Thomas. Okay, let's see Thomas here. The ERA score of Thomas is 2.77. And also Susan had the lowest ERA of any female teacher at a school with an ERA of 3.03. Therefore, here Susan has an ERA score of 3.03. Okay, remember that these are the data item. That means on the male, among the male teachers on the high school, this is the Thomas ERA, which is 2.77. Susan ERA is 3.03. Okay, everybody understand? For the male, the mean ERA is 4.158 and the standard deviation is 0.534. Therefore, here for male, because Thomas is a male mean is 4.158. Standard deviation SD is 0.534. For female, the mean ERA was 4.315. For female, mean is 4.135 and the standard deviation is 0.945. And the question is, find the respective z-score. Look at the question. Find the respective z-score and answer which player had a better year relative to the peers. Is this Susan has better year or Thomas has better year? Notice that in general, the lower the ERA, the better the pitcher. Okay, and for first thing you got to find the z-score here. Z-score of Thomas. How do you find it? Same formula, data item 2.77 minus mean 1.5158 divided by standard deviation, which is 0.534. And you subtract and divide, you get z-score of Thomas, which is going to be negative 2.6. Okay, notice that you rounded to nearest two decimal places, pretty much negative 2.60 or 2.6, doesn't matter. Now let's find the Susan z-score, the score of Susan. Okay, what's the formula? Data item 3.03 minus mean 4.135 divided by 0.945. And if you subtract and you divide, you get Susan z-score, I should say Susan score z-score gonna be negative 1.36. Okay, therefore you guys put here this answer. And last question is, which player had a better year in comparison to their peers? Remember that better years, lower ERA. Therefore, the person who has lower ERA has a better year. Therefore, Susan z-score is negative 1.36. This is Thomas z-score is negative 2.6, which is smaller. Therefore, in this case, Thomas had a better year because it's the lower z-score. Question number 6. A data item has a mean of 200 and its standard deviation of 50. Okay, data item in this distribution that corresponds to the given z-score. Okay, and here z-score is given, you got to find the data item. Alright, I should say, hey, data item which we don't know is x. Therefore, with the formula z-score gonna be data item minus mean divided by standard deviation. Okay, and since we have a mean 200 and deviation 50 and z-score negative 6.8, I'm going to put in the formula negative 6.8, z-score equals to x minus mean is 200 divided by standard deviation is 50. Therefore, I put all the information in the formula. Now I got to find the value of x, which is data item, and that's why we need to find the data item. And to solve for x, basically you multiply by 50 both sides of the equation, and this 50 cancel. 50 times negative 6.8, which is going to be negative 340, equals x minus 200. You add 200 both sides of the equation, you get x equals to negative 140. That's the data item that corresponds to z-score negative 6.8. Okay, let's do question number 7. Highly selective boarding school will only admit students who place at least 1.5 z-score above the mean. Listen, only those students who get at least 1.5 or above z-score from the mean, that can be admitted on the school. And the mean of all test score is 110 and the standard deviation is 12. Okay, what's the minimum score that an applicant must make on the test to be accepted? In other words, you got to find the score, the minimum score that the school must be accepted. In other words, you got to find the score corresponds to 1.5 z-score. For I'm using the same formula, Z score 1.5 equals to the score, which is the minimum score. I say, hey, minimum score is X. Pretty much X is the data item here, minus the mean is 110 divided by standard deviation, which is 12. Again, this is the Z score equals to the data item, what we are looking for, minus the mean divided by standard deviation. Okay, now you solve for the X, which is what we're looking for, multiply by 12, and you get 12 times 1.5 is 18 equals X minus this cancel 110. You add 1 and 10, and you get X equals to 128. Therefore, at least students should get 128 score to get admission on that highly selected boarding school. Question number 8. Explain the meaning of the accompanying percentile. The 10th percentile of the head circumference of male 3 to 5 months of age in the certain city is 41.5 centimeter. In other words, 10th percentile is 41.5 centimeter. Okay, what do you mean by 10th percentile is 41.5 centimeter? That's the question. And the answer of this question is going to be here, obviously. A, that means 10% data are less than 41.5 centimeter or less. Notice that, centimeter or less. Okay, you have or less here. That means 10% of 3 to 5 month old male have a blood circumference that is 41.5 centimeter or less. What do you mean by 75 percentile? Similar to the part A. In other words, 75% are less than 49.8 centimeter or less. In other words, this answer is C. 75% 2 years old female have a waist circumference that is 49.8 centimeter or less. Again, you guys notice here, centimeter or less. Okay. Part C. Anthropometry involves the measurements of the human body. The goal of these measurements is to assess the body, how body measurements may be changing over the time. And here the data, here you can see that how the age and the percentile 10 to 20 years, 29 years old, 10th percentile height is 160.6, and so on. And the question is, you can see that 80th percentile, the height generally, what happens? 80th percentile, look at here, height generally decreases, right? You can see here, all percentile height generally decreases, height generally decreases as the age increases. You see that? As age increases, height going to be decreases in its percentile. Assuming that an adult male does not grow after 20, the percentile implies that the adult born 90, 80 are generally taller, because this is the data for 2015, and since percentile decreases over the year, the people who born 90-50 must be shorter than who born 90-90, or adult born 90-90 are generally taller than the adult who born in 90-50. Okay. Question number 9 is similar to question number 8. Therefore, I think you can finish yourself. Question number 10. According to the National Center of Health Statistics, 19 years old female whose height is 67.1 inches, has a height that is at 85th percentile. In other words, this height is 85th percentile. So what do we mean by 85th percentile height is 67.1 inches? It's similar to previous questions. How do you interpret percentile? This means that 85% of 19 years old female have a height that is 67.1 inches or less, and 15% of 19 years old female have a height that is more than 61.7%. Okay, that's the similar to what we did before. Question number 11. What is the percentage of measurements that are above 39th percentile? Okay, 39% is below 39th percentile. 39th percentile. 100 minus 39% is above 39th percentile. And 100 minus 39 is 61% is above 39th percentile. Okay. Number 12. Violent crimes include rape, robbery, assault, and homicide. The following is a summary of violent crime per 100,000 population for all states of the country in certain year. And they're given is first quartile, second quartile, and third quartile of the violent crime. Okay, that means that many violent crime per 100,000 population. And question is part 1, provide the interpretation of the results. And another word, how do you interpret first quartile? How do you interpret second quartile? How do you interpret third quartile? First quartile means 25% or less. Violent crime is less than 272.88. Therefore, the answer must be C. You can read carefully here. 25% of state have a violent crime rate that is 272.8 crime per 100,000 population or less. Okay, you see or less here. And second quartile means 50% of the violent crime are less than this number. 50% of the violent crime is less than 387.4. Okay, and third quartile means 75% of the violent crime is less than 529.7 or less. Okay, that's the interpretation. Now, what's the range? You find the range, determine and interpret the interquartile range, not the range, by the way. It is interquartile range. Interquartile range is called IQR. IQR. And what is IQR? Here, IQR equals to Q3 minus Q1. That's the formula. And you have Q3 529.7, Q1 is 272.8. Put on the formula 529.7 minus 272.8, and you get 256.9. Therefore, in this case, interquartile range is going to be 256.9. And the next question, interpret the interquartile range. What's the interpretation of the interquartile range? That is middle 50% of the observation have a range equals to interquartile range. In other words, middle 50% of all observation have a range of 256.9 crime per 100,000 population. Okay, now next question is find the upper fence and lower fence for part C. We have the formula for that, and as you notice in the lecture, you have upper fence. I use UF. Upper fence formula is Q3 plus 1.5 times IQR. That's the formula. Q3 here is 529.7, right? Now 529.7 plus 1.5 times IQR is 256.9. 256.9. And if you use the calculator, do the math here, you get upper fence must be equals to 915.05. That's the upper fence, 915.05. Okay, to find the lower fence, let's write the formula for lower fence, which is this. Lower fence, LF for lower fence equals to Q1 minus 1.5 times IQR. Okay, now you have Q1 and you have IQR. What's Q1? 272.8 minus 1.5 times IQR is 256.9. 256.9. And if you use a calculator, and you'll find that lower fence is going to be negative 112.55. Okay, that's the lower fence, negative 112.55. And next question is this violent crime of certain city was 1679? Is that outliers? Is that number is outliers? 1679 violent crime? The answer is yes, because if you look at the upper fence and lower fence, this number is not in between. Anything outside the fences or bigger than upper fences, smaller than lower fences are called outliers. The answer is yes, because it is greater than upper fences. Notice that this number is greater than upper fences. This outside the fences, this number, therefore it has outlier. Do you believe that the distribution of the violent crime rate is skewed or symmetric? Of course, the violent crime rate is skewed. Why? But you have to see what direction it's skewed. Okay, notice that there is a way to check it. You find Q3 minus Q2, okay, and you find Q2 minus Q1. And if Q3 minus Q2 is bigger, and that is skewed right. It's skewed right. Alright, therefore pretty much you got to find Q3 minus Q2, find the number, and Q2 minus Q1, find that number, and check which is bigger. If this is bigger, Q3 minus Q2 is bigger, we call skewed right. Let's see. And let's put the value of Q2, Q3, Q1 in this inequality. It should say that the value we have here on the top. Okay, let's put that Q3 minus Q2. Let's find it. What's the Q3? Q3 minus Q2 gonna be 529.7 minus 387.4, which gives 142.3. Okay, now what is Q2 minus Q1? Let's do the same thing. Q2 minus Q1 equals to 387.4 minus Q1 is 272.8. If you subtract, you get 114.6. And you notice that Q3 minus Q2 is greater than Q2 minus Q1. You see that? Therefore, this is skewed right. The answer for this question is A. The distribution violent crime is skewed to the right. And if the other way happens, if this is less, it's going to be skewed to left. That's the other way. Now, question number 13. Accompanying data represents the miles per gallon of random sample of cars with the 3-cylinder 1.0 liter engine. Therefore, you see this random sample of those mile per gallon of the car. Okay, and here you have a different part here. First part is asks you compute z-score, okay, and interpret the results. And second part asks you to find the quartiles q1, q2, q3. And third part asks to find the interquartile range. Interquartile range. And finally asks lower fence, upper fence, and checking for outliers. Okay, to do that, let's put the data in the calculator first. Okay, you do the start and number 1, which is edit. And if you have data in the calculator, you can just clear it. Okay, like that. Just clear and press enter, and everything is clear. Now doesn't matter where you put the data. I usually put data in L1. Okay, here L1, and you just type the data. Here's the data: 32.6, 32.6, 34.1, 34.6, 35.6. Okay, I'll be back. Okay, I put all this data in the calculator. Now to find the z-score, you got to find the standard deviation first. Notice that this is the sample data, therefore I'm looking for sample standard deviation. Alright, now to find that, you go to the start and calc, and remember that start calc and function 1, which is one for stat 1, and since your data is L1, you're good. Press enter. Okay, now you see that you have a standard deviation that is here. That's what you're going to use. Remember, this is the sample standard deviation, and let me write it down there for you. It's 3.48. okay, therefore sample standard deviation equals 3.4. I'm going to use that because this is the sample data. Okay, you see that sample data. Alright, now you're looking for z-score. Therefore z-score going to be is data 38.2 minus mean, which is going to be in the calculator. You have the mean 38.98. That's what you're going to use, 2 decimal places. 38.98 divided by standard deviation is 3.48. Which one is here? And if you divide here, you get negative 0.2162. Since you rounded to 2 decimal places, this is going to be approximately 0.22 negative. Therefore z-score is negative 0.22. And you have to interpret that z-score negative 0.22 indicates that the data value is 0.22 standard deviation below the mean. Below the mean. MEAN mean. Okay? Below the mean. Let me write it properly. Below the mean. In other words, that data value 38.2 miles per gallon is 0.22 standard deviation below the mean. Now next question, find the quartiles Q1, Q2, Q3. If you look at the calculator, you'll see quartile here under this arrow. You can find Q1 is 36.9, Q2 is 38.65, which is median. This is Q2, 38.65 median. Q3 is 40.95. Let me put this number. Q1 going to be 36.9, Q2 going to be 38.65, Q3 going to be 40.95. Next question is compute the interquartile range. Interquartile range is IQR equals to Q3 minus Q1. That's the formula. Q3 is 40.95 minus 36.9, and if you subtract, you get 4.05. 4.05. That's the interquartile range, and this is the range of the middle 50% of the observation. That's the interquartile range. Okay, observation. All right, now determine the upper fence and lower fence. And we have the formula for that. Upper fence is gonna be, let me write the formula. Upper fence equals to Q3 plus 1.5 times IQR. Lower fence is gonna be Q1 minus 1.5 times IQR. Okay, since you have Q1, Q2, Q3 and IQR, use this number to find the upper fence and lower fence, and use the calculator. You will find that upper fence must be 30.825 and the lower fence must be, oh, this is lower fence. Lower fence must be 30.825, upper fence must be 47.025. And the next question is, are there any outliers? And the answer is yes, because look at this number 48.9, which is larger than upper fence UF. Okay, therefore you have an outlier. Therefore the outliers is, select A, and 48.9. Okay. Question number 14. The companion data represent the wait time in minutes for a random sample of 40 visitors to an amusement park. Remember that this is also sample data, and the data is going to be wait times. Okay, and you have to complete part A to B. Pretty much in the part A and B, you're looking for quartiles and checking for outliers. That's what you're going to do. Let's find the quartile. To find the quartile, you got to put the data in the calculator. Basically, you're looking for Q1, Q2, and Q3. Okay, therefore, to put the data in the calculator to find Q1, Q2, and Q3, you got to use start option here, and number one is edit, and you got to put in L1 or L2, doesn't matter. Let me put the data in L2. Okay, alright, and we just highlight this box and start putting data L1. Let's put the first row, sorry, first column, second column, third column, and so on. Let's put the 7. Let's put the data 7 here. Enter. Let's put the data 8. That data 8. And let's put the 20. And so on. Let's put all 40 data. I'll pause the video and I'll be back. Okay. Okay, I put all 40 data in the calculator. And let's answer the questions. Determine and interpret the quartile. That's the question. And by the quartile, about how many percentage of the wait times are Q1 minutes or less. Okay, let me write down quartile first. Q1 first quartile, and the box has to be oh, I got to find it. Q1, Q2, Q3 first. You go to the start and you select calc number 1. Okay, and since your data in L2, I just type L2 here, which is under 2. Therefore I'm going to do second and 2 and L2. And that's my statistics. Here, and scroll down, I find the Q1 is 5.5, median as a Q2 8, Q3 as 18. Therefore what I'm going to do here is I write Q1, which is going to be 5.5, and I write Q2 here, which is going to be 8, which is median, and the Q3, which is going to be 18. Again, you guys get that from the calculator. Okay, Q1, Q2 and Q3. Now you have to fill in the percentage here. In Q1 means 25% of the wait time are 5.5 minutes or less, and 75% of the wait time are bigger than Q1 or exceed Q1 minutes. The Q1 here is 5.5 minutes. And about 50% of the wait times are Q2 minutes or less. Remember that 50% of the wait time are less than median, which is Q2, and about 50% of the wait time exceed Q2 minutes. Okay, you already have a percentage on the back of the box. And about 75% of the wait time are Q3 or 18 minutes or less, and about 25% of the wait time exceed Q3 minutes. Okay, that's the answer. Now next question is, does the data set have outliers? To check the outliers, you got to find the fences. Let's find the upper fence, UF, with the formula Q3 plus 1.5 of IQR, and Q3 here is 18 plus 1.5 times IQR is, no, let's find the IQR. IQR equals to Q3 minus Q1. Q3 is 18 minus Q1 is 5.5, which is going to be 12.5. Okay, therefore I put the IQR here, 12.5, and if you do the math here, you'll find upper fence as 36.75. And how about the lower fences? And we have the formula for lower fences, which is gonna give lower fence gonna be Q1 minus 1.5 times IQR. Okay, Q1 is what? 5.5 times minus 1.5 times IQR is 12.5. Okay, 12.5. And if you subtract here, your answer is going to be negative 13.25. This is the lower fences. This is the upper fence, this is the lower fence. Anything beyond this fence is going to be outliers. And here you'll find that two data here, technically 44 and 52. See, these two data are above upper fences. Okay, therefore outliers are 54 and 52. That's the outliers. Okay, next question. Explain the circumstances for which the interquartile ranges prefer measure dispersion. In this question, it asks you why interquartile range is preferred measure of dispersion. Why? What's the advantage that the standard deviation has over the interquartile range, and what's the benefit or advantage of using standard deviation over the interquartile range? The answer is, if you read all the options, answer is B, because interquartile range is preferred when data is skewed or have outliers. By the time interquartile range is good measure for dispersion, and advantage of standard deviation is that it uses all the observation in its computation, but interquartile range is only Q1 and Q3, but standard deviation is all the observation. Therefore, it is advantage over, or it has advantage over interquartile range. Number 16. If you look at the questions and you try to find what is cutoff points, okay? Again, I'm not going to do this question. Cutoff point is upper fence. How do you find the fences? We just did a couple of questions before. You find upper fence only. That's the answer for cutoff point.